Good morning to all. In the previous session, we completed solved examples on energy and power signals. In this session, we are going to have discussion on a small topic that is called coefficient of approximation in Fourier series. In university, they are asking a small question on this topic alternately. Let us start coefficient of approximation in Fourier series. Now, so in this topic, we are going to start coefficient of approximation. Coefficient of approximation in Fourier series. This term is important. Fourier series. Now look at here. What is coefficient of approximation? It should not be like that. Coefficient of approximation in Fourier series. Now let's just look at here. In Fourier series, coefficients in Fourier series can be expressed individually. It can be expressed as an individual one or in all in one. All in one or individual. Each and every signal every coefficient can be expressed individually, or all three coefficients can be combined in a single coefficient. Now, in Fourier series, this is called Fourier series individual response. This is called Fourier series individual response. Here, the coefficient can be A0, and here it is AN and BN. Three coefficients are there because the given signal x of t can be written as 1 by 2 A0 summation 1 to infinity AN cos n omega naught t plus sin n omega naught t. In this way we write plus Bn sin n omega naught t. That means what? A0 1, An second coefficient, Bn third coefficient. In this way, in Fourier series, general Fourier series, three different coefficients are appearing. Now, all these coefficients can be combined in a single coefficient that is called what? All in one. In this way, we call it as coefficient of approximation in Fourier series. Look at this is called coefficient of approximation in Fourier series. So the topic is coefficient of approximation in Fourier series means students have to understand that it is not the discussion of individual coefficients. It is the discussion of combining all the three coefficients in a single coefficient that is called coefficient of approximation in Fourier series. Here it is singular, only coefficient. Here it is plural, A0, An, Bn, coefficients in individual format. It is only coefficient. Now just look at, in this coefficient, how a signal can be represented. This is equal to summation minus infinity to infinity e power j into k minus n omega naught t. This is the signal representation. X of t. X of t can be represented as in this signal, in this format way, where here was some constant that is equal to C of k. This is C of k constant is called coefficient of approximation in Fourier series. Now just look at, this is also signal. Here also a signal x of t. Here this x of t could be expressed in individual coefficients. This signal format can be expressed in single way. This is a theoretical approach. A problem can be solved either in this way or in this way, but this way is very easy to calculate, understand. Now just look at here, where what is coefficient of approximation? This is equal to 1 by t integral 0 to it e power minus j k omega naught t dt. This is called, this C of k is called coefficient of approximation. This is called coefficient of approximation. Coefficient of approximation in Fourier series. Look at this C of k. That means what? If a signal is given, the signal could be expressed in a single coefficient. That's why it is a coefficient. Just we are approximating coefficient of approximation in Fourier series. Now let us make some properties it has. Same properties now we are going to discuss on this one. Let us start. Now, what properties it is having? The properties that can be discussed on coefficient of approximation in Fourier series. Now just look at here. I am writing in a simple format because of the time consistency. So properties on coefficient of approximation in Fourier series. What is the first property? The first property is called linearity property. Second property is called scaling property. Third property is called shifting property. Fourth property is called time reversal. Time reversal. All these are linearity, time scaling. This is time shifting. This is time reversal. Fifth property, multiplication property. Now, multiplication property. The sixth one property is called convolution property. Convolution property. Now, just look at. We are going to discuss all these 5 properties under coefficient of approximation in Fourier series. Now, actually, a question we can expect on this topic with only 2 marks, or 2 marks or not more than that. Maximum they may give for 3 marks or not more than that exactly. Now, just let us discuss each and every property individually. Now, first property is called what? Linearity property. What is linearity property? Now, students have to recollect the important concept of linearity. Whenever we discuss linearity, 2 signals should be there. Let the 2 signals be x1 of t and the x2 of t, 2 signals. And also let 2 coefficients. What are the coefficients? B1 and B2. 2 signals we need. For each signal, 1 coefficient. So 2 signals are there, 2 coefficients are there. So linearity property means what? Now just look at. Now we have to find, what we have to find? Fourier series coefficient. Every signal has its own Fourier series coefficient. Now just look at. Fourier series coefficient of the signal x1 of t is equal to some function of x1. For understanding purpose, you can make it Fourier series coefficient of a signal x1 equal to f of x1. Similarly, Fourier series coefficient of another signal x2 of t equal to, let it be f of x2. Let us assume like that. Now, what is linearity property? Fourier series coefficient of signal x1, coefficient b1, multiply b1 x1 of t plus coefficient b2, multiply with the second signal b2 x2 of t. This is equal to Fourier series coefficient of b1 x1 of t plus Fourier series coefficient of b2 x2 of t. Individually split the given whole term. This will become b1 is coefficient, make out of the function. So b1 into Fourier series coefficient of x1 of t plus b2 is constant, take it from out of the function. That is b2 into Fourier series coefficient of x2 of the signal. Now just look at. In the previous one, Fourier series coefficient of x1t how much? F of x1. So b1 in this place we are writing f of x1 plus b2. Now in this place look at the second one. What is its value? F of x2. Now so that means what? Fourier series coefficient of sum of a superposition signal. Superposition means what? We have to make it linearity property. Superposition signals is equal to sum of Fourier series coefficients of individual signals. Fourier series coefficient of sum of two signals is equal to sum of Fourier series coefficients of individual signals. The same property what we discussed in the linearity property at the beginning of the signals. Same concept just we are using here. That's why this is called a linearity property. So this is the first property under coefficient on approximation in Fourier series. So first property is over. Now just look at second property you are making it. What is the second property? The second property is called time scaling. For time scaling we need only one signal. Let x of t be the signal. Its coefficient x of t be the signal. Now in signal property what is time scaling? In the previous case what we discussed, x of alpha t is the time scaling factor. Now just look at here. Let the Fourier series coefficient of a signal x of t equal to f of x. In the previous case, two signals x1, x2. So individually we defined fx1 and fx2. Here scaling, for scaling no need to take two signals. It is enough to take only one signal. That's why just I have chosen x of t be a signal. Now let Fourier series coefficient of that single signal x of t is equal to f of x. Now what is time scaling? Here time scaling is equal to, for time scaling what we need? Alpha. So now Fourier series coefficient of x of alpha t. Now just look at where am I keeping alpha? I am keeping alpha as a scaling factor which is multiplying the individual variable of time t variable t, alpha t. I kept alpha here, make it a point. This is equal to, now just look at. In general, Fourier series coefficient of x of t how much? F of x. You write the same f of x. Now here alpha is multiplying. So here just you keep alpha here. So this is the time scaling factor of coefficient of approximation in Fourier series, the second property. So no need to by heart the concept. You are just observation. We need only your observation on this. The Fourier series coefficient of any given signal is f of x. Now here same f of x here we are writing. Now just look at same f of x we are writing here. But what is alpha here? Alpha is what? A scaling factor. Now here alpha is multiplying the individual time variable small t. Here alpha is multiplying the coefficient conversion x, f of alpha x. This is the second property of coefficient of approximation in Fourier series. This is the second factor, second principle. Now, in the next session,